continuing the problem, we have 2 points on a line. We need to find the equation of the line. So we learned before that we need to find the slope, and the slope should be the rise over the run. So that's the change in y over the change in x. So that means I need to subtract the y coordinates, so 3 minus 2.5. That's the difference in the y coordinates. That's our rise, or in this case it's actually falling. And then the run from 4,000 to 450 would be, 4,000 to 4,500, 4,000 minus 4,500. So again, for finding slope, the only thing that matters is that the coordinate pairs are in the same order, top and bottom. So 3 goes with 4,000, 2.5 goes with 4,500. So that's the correct fraction for slope. In the numerator here we have 0.5, which is a half. And in the denominator we have negative 500. So the slope here, if I actually wrote that as a fraction, would be negative 1 over 1,000, which is negative 0.001 if you want to write it in a decimal. So you can write it either way. But that's our slope. And so the point slope form of the line that we talked about in the line review said that we should write y minus blank equals the slope, and I'll just write it as a fraction because that's easier for me without a calculator in front of me, x minus blank, and the blank should be filled in with the x and y coordinates of one of our particular points. So I'll just use this one just because it seems easier to write down. Y coordinate of that point is 4,000, and the x, oh, excuse me, that is not right. The y coordinate of this point is 3, and the x coordinate of this point is 4,000. So over here on the right-hand side, I have negative 1/1000th x, and minus 1/1000th times minus 4,000 is plus 4. So now if I add the 3 to both sides, I'll have y equals, and over here I'll have negative 1/1000th x plus 7, and on the left-hand side I'll just have y. Now notice here that the y coordinate is actually price, so really I should write p here instead of y. But this is my price demand equation. And so that would be the answer that goes right there. Now, what do we do with it? Well, we use that equation we use this equation, this price demand equation, to build our revenue function, because the revenue function, and we used this in one of the previous problem sets, revenue is price times sales, how many you sell. So that's price times x. X is how many that we're selling at that particular price. And we have a formula up here for price. So price is negative 1/1000th x plus 7, and that's multiplied by x, the number of things sold. So that's price times the sales level. So that's how much money we're bringing in. If I sell, what did we say, 4,000 hot dogs at $3 each, then this function will turn out to be 12,000. It's the price you're selling them for, the $3, times 4,000 hot dogs. So that's a fairly straightforward thing. The rest of the problem is going to be about, or eventually the problem is going to be about profit. So I also need a cost function. And so we have to be able to do an analysis for cost function from this word problem. What do they tell us about cost? Well, they tell us that fixed costs are 17, this number here, 1779.70. Fixed cost means that those are the costs that you incur without selling anything. So that's salaries and utilities or anything like that that you will have to pay regardless of whether you sell a single thing. So now it's going to challenge my ability to remember the numbers. Hang on. 1779.70. So that's the fixed cost. So that's added to the cost for anything at all that we have to make. The variable cost is $1.82 per hamburger. So remember, X is the number of hamburgers. So that means that I have a cost of $1.82 times X. So this is my cost function. my fixed cost and then my variable cost. The variable cost means how much it costs from actually stocking and making the hamburgers. So profit then is just revenue minus cost. So I would take the revenue function that I have created and subtract the cost function that I've created. And now you'll be able to do any of the questions. If it asks about marginal revenue, if it asks about marginal cost, if it asks about marginal profit. Any of those things are easy to do now that we have all three formulas. We have our revenue function, our cost function, and then our profit function. So this problem has a lot going on with it, but a lot of it is sort of general business applications that you really need to know about, like revenue is price times sales, and profit is revenue minus cost. And also this idea of fixed cost and variable cost. So all of those components are important here, but once you've distilled all the information out, then the marginal analysis is actually not too bad. The calculus part's not too bad.